So here we have a bakery that is selling bread, or they're ordering. Wait, it says a bakery kept a record of the number of loaves of bread a tuck shop ordered. Okay, over the last 18 days. So here's the 18 days over here. Calculate the mean. Okay, so the mean is very easy. You just add all of these numbers together and you divide it by how many numbers there are. So you're literally going to say 10 plus 11 plus 13 plus 14 plus 14. So you're just going to add absolutely everything together, and then you're going to divide that answer by how many numbers there are, which is 18 different numbers. And if we do this, we should get a lovely answer of 22. Now the next one asks for the standard deviation. So for this one, you want to definitely just do it on your calculator. Yes, in grade 11 we learned this long way of doing it without a calculator, but for 1 mark, come on guys, I'm sure we don't want to be wasting that much time. So I've got my calculator here, but I'm just going to quickly write that this was a 18 and this was a 41, because my calculator blocks that out the way. And so we're just going to go fill in all the values. So 10, oh wait, we should probably put our calculator into stat mode. Okay, so mode, stat. We're going to look for the first one, so you're just going to push number 1, and then you're just going to enter your values. So 10, 11, 13. See you guys, so, and then if there's a 14, you can just say 14 multiple times. Some calculators have a frequency column, so you could do it like that if you wanted to. It's not necessary. 16, 18, 18 again, 19, 19 again, 20, 21, 35, 35 again, 37, 40, and 41. Okay, then what you do is you just say, you push the on button, and you can go shift, and then down here to stat, which is number 1, and then we're going to go to number 4, and we're going to push number 3, because that's standard deviation, and that's going to give us 10.17. Okay, so for our standard deviation, we got 10.17. Then it says the number of days in which the number of loaves was more than 1 standard deviation above the mean. Okay, so if the mean is 22, then they said 1 unit more, so that would take us to, so I'm adding on 10.17 because that's 1 standard deviation. That's how big 1 standard deviation is, and that would be 32.17, right? So they want to know on how many days was it more than 1 standard deviation above the mean. So anything more than 32.17. So that would be this number, this number, this number, this number, and this number. So that's 5 different days. So you'll just say 5 days. Remember that these questions are carrying on. Okay, so just remember that even after this question, the questions are still going to carry on after this. Okay, I just can't fit everything onto one slide. So it tells us that the tuck shop owner was not able to sell all of the loaves. He calculated the mean number of loaves sold over the 18 days to be 20. Okay, but earlier on we calculated it. Remember what our original mean was? It was 22. But he didn't manage to sell all of them. So his new mean, his new daily average was 20 because he wasn't able to sell everything. So it says calculate the number of loaves of bread which were not sold over the 18 days. So let's look at the original first. The original, you had 18 days and each day you sold 22 loaves. That was your mean. Remember that? So let's see how many loaves of bread we would have had. 396. So if you had to go add all these numbers together, that's what you would get. But now the new mean, he only sold, over the 18 days, he sold 20 loaves per day. And so if you had to go work that out, you get 360. So if you minus these two numbers, you get 36. So there were 36 loaves that he did not sell. Alright, and then here's the last question. So it says one of the two box and whisker diagrams drawn below represents the data given in the table above. So this is still a carry on from the bakery. And it says which one of the two box and whiskers drawn correctly represents the data. Write down a reason for your answer. Okay, so obviously the minimum is 10. but we can see that that's the same for both. 41 is the maximum. That's what they've got, and that's what they've got. Okay, so it wasn't going to be that easy for us, hey guys? Now, I think what we can go do is we can go work out the median, for example, and we can see what that is. So we know that the median is n plus 1 over 2. So we know that there were 18 points, or 18 days. And if you had to work out 19 divided by 2, that's 9.5. So for that, you go to position number 9 and position number 10. So position, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you take the average between those two numbers. So you add them together, and then you divide them by 2, and that's going to give us 18.5. And so if you look at this median, it's on 30. And if you look at this one, it's on, it's like in between those two, so that's 18.5. And so we can definitely say that it's graph B. So we can say graph B, and then we can say median is 18.5. Okay, then it says describe the skewness of the data. So now we obviously, they didn't make this one so clear, but we're obviously not going to look at A because that's not relevant to this question. So let's look at the skewness. What you do for skewness is you just look at the median, okay, and you look from there. You look at the length. So look at that length, and then look at that length over there. Now the one that's longer is on the right, so we will say skew to the right. The one that's longer from the median, you're going to say that it's skew to that side. Or for some learners, I know you might even want to say positively skewed. That's also okay. Positively skewed. So here's the first one. I've done my best to try get the answer diagram. They gave, or they will give you this in your exam. And then here's the values. They even give you the y-axis, the x-axis. So it's pretty easy. So the x-axis is price of milk. So that's this one. And then the y-axis is number of 5 liters. So that's that one. So the first point to plot is 26 and 48. So we can see here that this is 25 and this is 30. So that means that this is 26, 27, 28, 29. So it's going up in ones. And this is 21, 22, 23, 24. So it's going up in ones in both directions. So 26 would be here. And then 48 on the y-axis would be here. So where those two lines cross would be over there. And so that is where you would put our first little dot. Okay. The next one is 32 and 30. Which would be there, okay, and then 36 and 26, and then 28 and 44, 28 and 44. All right, and then 40 and 23 would be over there, 40 and 23, and then 33 and 32, so 33 would be there. And then 29 and 39, so 29 and 39 would go there. 34, 29 over there. And then 27 and 42. Geez, I'd hate to be the person that has to mark all of these. Must be so boring. 27. Okay. And then 30 and 33. 30 and 33. Okay, so there is our scatter diagram. So we now have to work out the equation of the least squares regression line. So in grade 12 statistics, we don't use mx plus c, we rather use a plus bx. It's quite interesting. So you're going to just put all these values onto your calculator, but let me show you how. So you're going to put your calculator into stat mode like we normally do in grade 11, but now you're not going to choose option number 1, you're rather going to choose the option that has a plus bx. So on my calculator, that is number 2. Then I'm just going to put my x's and my y's. So the x is 26 and the y, well, let me first put my x's in. I like to do that first. So 32, 36, 28, and then after that I'm just going to go put in my y's. Okay guys, so pretty straightforward. Now I'm putting in the y's, so that's 30, 26, 44, 23, 32, okay, 39, 29, 42, and 33. Okay, what you then do once you've done that is you can just push the on button or AC. Then you go shift mode. Now we're looking for number. We're not going to say 4 because that was grade 11. Now we're going to say 5 for regression. And we're going to get the A value and the B value. So you say A equals. So I'm just going to write that down on my piece of paper here, because if I write it on the screen, then the calculator disappears. So you should get 90,48, and let's keep that to 2 decimal places. So that's 90,48. For B, you're going to go shift stat again, number 5, but now you're going to go for B, and then must say equals. There we go. So you must say equals 1,77, and I'm just going to go get R, the correlation coefficient, just in case they ask us for that later, and then we don't have to go do everything. So we look for R, and that's going to be push equals, and that's negative 0,94. So now we can fill in the values. So we said that A was 90,48. You can say 90,48 minus, because B is minus, 1.77x. Now the next question says that, okay, so let's just remember our previous answer actually. I think this one might have something to do with it. So we said 90.48 minus 1.77x. Okay, so it says if the farmer sells a 5-liter container of milk for 38 Rand. Okay, so price of milk of a 5-liter container, he got 38. Predict the number of 5-liter containers of milk he will sell. So they're pretty much telling us, so they're giving us, that's a X value. See, because it's price of milk in rands for a 5 liters. That's your X value. So this is X. And then it says predict the number of 5-liter containers he will sell. 5-liter. So number of 5-liter, that is your Y. So they just want us to use this formula now. So you're going to plug in X as 38. And then you're just going to go solve. And that's going to be 23,22 Rand. So 23,22 Rand. Now it says refer to the correlation. Aha, so that's your correlation coefficient. So I showed you guys how to do that already. So you would want to calculate that for them. And we got negative 0,94. Now remember, what does R tell us? R tells us how the X and Y correlate, and if there's a good relationship between them. So what that means is, if you know the price of the milk, can you then work out the number of units sold? Like, will it be very accurate or will it not be very accurate? So R, and remember, we've looked at this in other lessons where we show the different values of R that you can get. And sometimes we call it strong, sometimes we call it average, sometimes we call it weak. The negative just means that it's got a negative gradient, so don't worry too much about that. But what this tells us, this 0.94, is that the correlation is very strong. So we can say that the correlation, so you'd first show them what R is. You would say R is equal to 0, R is equal to negative 0.94. And then you would say the correlation between price of milk in rands per 5-liter container and number of 5-liter containers sold is strong. So it says comment on the accuracy of your answer in 2.3. So in 2.3 we had to predict what the oh, I see in my previous answer I said Rand, but that answer wasn't meant to say Rand. That answer was just meant to say units. My bad. Okay, so that answer that we got in 2.3 was 23.22. Remember, we got 23.22 units. Now that answer would be very accurate because this number is very close to a 1 or a negative 1. So we can say that the answer from 2.3 has a high chance of being accurate. It has a high chance of being accurate. So let's begin. So the first question, or what they tell us here is that we've got A, B, okay, we can see B, C, are the vertices, line BC is produced. Okay, there's nothing interesting here. The angle of inclination is 81.87. Okay, so everything they've said we can see. So the first question for 2 marks, calculate the gradient of BE. Where's BE? Okay, so BE is here. Now, many learners, or some learners, they would get stuck here. They'll say, how am I supposed to calculate the gradient if I don't know what these coordinates are? But remember, you can use any 2 points on the line. So we'd use the gradient formula, which is y2 minus y1 over x2 minus x1. And so I'm going to use this as my point number 2, and this is my point number 1. So that'll become 0 minus 2 over 12 minus 4. And that's going to give us 2 over 8, which is a quarter. Okay, so that's easy, a quarter. Now they want the gradient of AB. Now remember that I want you to remember the following. If you know the gradient, then you can work out the angle, and vice versa. If you have the angle, you can get the gradient, and if you have the gradient, you can get the angle. And the way that we do that is by using tan. So you can maybe write the following down. Tan of the angle gives you the gradient. And what tan am I talking about? I'm talking about like sin, cos, and tan, that tan. Okay, and then if you have shift tan, so this means shift tan of the gradient, then that would give you the angle. Okay, this is from like angle of inclination type of stuff. So we have this angle over here. So if I want to work out the gradient, I can literally just go the gradient of AB is just going to be equal to the tan of 81.87, and that's going to give 7. It's a perfect 7. We're now on to the next set of questions, and what I will do throughout this lesson is I will just keep writing down any answers that we have, just in case we need that for some of the future questions. So in this one they say determine the equation of BE, so that's just the straight line BE. Where's BE? Oh, okay, BE is this one here. So to work out its equation, it's y equals to mx plus c. We already know the gradient of that line from the previous question as 1 over 4. To find c, you just plug in a point. You could choose this one or this one if you want to. Doesn't really matter. I'm going to use the 12 and the 0. Like that. And we should end up with c being -3. Eventually. And so your final answer for this one would be y is equal to a quarter x minus 3. Here's the next set of questions. So this one says calculate for 2 marks the coordinates of B. Okay, so B is over here. So it's quite interesting. So we can just take the equation that we got in the previous question, which was y equals to a quarter x minus 3. And we can just go plug in these 2 points. Luckily, they're actually the same. So the y is a k and the x is a k. So now we're just solving. So I'm going to take this quarter to the left. So you're going to end up with 1k minus a quarter k equals to minus 3. Now 1k minus a quarter k is just going to be 3/4 k, like that. And if you had to go solve this, you should end up with k is equal to minus 4. And so it'll be minus 4 for both. So you could say minus 4 and then minus 4 again. Okay, now the next question for 4 marks wants us to calculate the angle of A. Now guys, I'm going to show you something. I see these types of questions popping up so many times. So let me just, you can make some notes on this. They'll often do this. They'll give you like a triangle. Something like that. Actually not like that. More like that. Okay. Whatever. And there'll be a triangle, and they'll ask you to find this angle over here. All that you do is you work out this angle. Now how would you work out that angle? Well, that would be using the gradient of this line. Remember, as long as you have the gradient, you can work out the angle just by using tan. And then you would also somehow work out the gradient of this line. So you could get this little angle over here. And then once you've done that, you have angles in a triangle, and then you can work out this angle over here. So in this one, your triangle, don't use this as your triangle, by the way. You're not using that as your triangle. You want your triangle to have a horizontal line, okay? Because a horizontal line allows you to measure the angles. right? So like you can only use the tan method that I spoke about if you have a horizontal line. So you'd typically go for something like this instead. So we already have this angle. So all that we really need now is this angle. And then you can just get 180. Okay, but don't use this line, guys. Don't use that line, and don't use that triangle, because then you don't have a horizontal line. Then you technically have to go work out that angle and that angle. And remember earlier, I said that if you have the gradient, then you can get the angle and vice versa. But this is only when you are working off of a horizontal line. This is not a horizontal line. Horizontal line is perfectly flat, like your x-axis, for example. Okay. So I say we work in this triangle over here. And so we already know this angle. Now we just need to get this angle. So we can work out the gradient of this line over here. So let's go do that. So we can work out the gradient of AC. Let's just write out the formula, y2 minus y1 over x2 minus x1. It doesn't really matter, but I'll let this be point 2 and this be point number 1, just so you can follow along. And so that's going to be 10 minus 2 over minus 2 minus 4. And that actually gives us 12 at the top, minus 6 at the bottom, so that's negative 2. So we now know the gradient of this line is negative 2. So now remember what I told you. I said that the tan of the gradient can give you the angle, but you have to use the shift. And very importantly, don't use the negative. Don't use the negative. So to work out your angle, you can just go shift tan. So you say shift tan of 2, and that's almost like your reference angle, and that's going to give you 63.4349, and it goes on and on. Now, if you look carefully, that's relative to a horizontal line, right? So that could either be this angle or it could be this angle. But now, if you look at 63.43, it's definitely the smaller angle, so it's this one over here. Okay, so then we can say, therefore, angle AGO, for example, AGO is 63.4349. Now we can work out this angle A by saying 180 minus 63.4349 minus 81.87, and the reason for that is sum angles of a triangle. And if you had to work out angle A, we should get 34.70 degrees. Moving on to the next question. So it says the coordinates, find the coordinates of the point of intersection of the diagonals of the parallelogram ACES, where S is a point in the first quadrant. So ACES, okay. So it would go A to C, then to E, and then S would have to be somewhere over here. That would make some type of parallelogram shape. Now, to find the diagonals, well, we know that the diagonals do this, right? There. So you could find the intersection of using that, but that won't work because you don't know the coordinates of this point. We could find it, but it's not necessary. You can also just find the... Whoopsie, Kevin, where are you going, dude? You could also just find the midpoint of this from A to E, because the midpoint of a parallelogram is the same no matter which diagonal you use. So it says find the point of intersection of the diagonals. So you don't have to use this diagonal. That's not going to work. It's going to take longer. So you can just work out the midpoint of this one. Okay, so we are going to work out the midpoint of the line AE, and so the midpoint formula is just x1 plus x2 over 2, y1 plus y2 over 2. And so that's going to be, I'll use this as my point number 1, and this is my point number 2, and so that's just going to be 12 plus negative 2 over 2, and then the y's will be 0 plus 10 over 2. And so that's eventually going to end up giving us 5 and 5 again. Okay, so the intersection will be 5 and 5. Here we are told that another point, which is point T, is P and P, where P is positive. Okay, well if this quadrant's positive and this this value's positive, then T would be somewhere in this quadrant. Okay, think about that. If both of these are positive, then it's somewhere here, such that ET, so from E to T, is the same as B to E. Okay, so they're saying that this, and we worked out K earlier as -4 and -4. Okay, so they're saying that this length is the same as the length from B to E. So from B to E, which we don't know where, sorry, from E to T. My goodness, Kevin, get your words. From E to T. So we don't know where ET is, but I mean, it could be like there, for example, or it could be there, for example, or it could be there, for example. We don't know, but we know that the lengths are the same, and they're telling us that that length is 4 square root 17. And if you just had to go check it out anyway and go work out the length from B to E, you would actually see that it is 4 square root 17. Right, now, okay, so let's just go say this. We know that the length from E to T is 4 square root 17, right? From E to T. Now, T we don't know, but we know that T has coordinates of P and P. So we can just go use the distance formula, which is this, not squared. And let's just guess where T is. Maybe T is here. Okay, so we say T, and it's got coordinates of P and P. So I'll use this as point number 2, and I'll use this as point number 1, and so we can do the following. So we can then say 12 minus P squared plus 0 minus P squared equals to 4 square root 17. Then what I would do is I would square both sides, because mathematically I can do that, and then it gets rid of any square roots. Be careful though, hey guys, this 4 is going to be squared because it's not inside the square root, so look out for that. So I'm just going to work over here now. So what you'd end up with on the left hand side is just everything that was in the square root, and then on the right hand side, if you had to go type this on your calculator, you end up with 272. Now it's pretty basic, eh? Now we're just going to go solve. So I'm going to multiply this out here. So this would eventually give us that. And then this would just become positive P squared equals to 272. And now it's just a matter of solving. So we end up with 2P squared minus 24P. And then 144 minus 272 is minus 128. Now you can try factorize this, or you can just solve it using factorizing. It's completely up to you, but I'm just going to go use the quadratic formula now, okay? And if you do that, you should find out that P is going to be the following. P is 16, or P is minus 4. But they did tell us that P must be a positive number, so we'll put a line through that one over there, and so the answer is 16. So P is 16, so that means the X and the Y are 16, because they're both the same for point T. Okay, so point T has coordinates of 16 and 16, in case we need that for future questions. Actually, 16 and 16 would be more like here. Or maybe a bit more vertical, so maybe here. Okay, because I think the next question talks about this. So it says that determine the equation of the circle with a center at E and passing through B and T. Damn, this is going to be one big ass circle. So it's got a center at E, and it's going to pass through T, B, and T and B. Jeez, like. So it's going to be something like that, okay? Because we all have time to be drawing stuff like that when we're in our exam. So it says calculate the with center. Okay, so this is the center. Okay, guys, this isn't actually that bad. So that means that these lines are the radii, And that's why it's only 2 marks. It's actually pretty straightforward. So if the center is at 12 and 0, then your circle equation will just go like this. Okay, and then this is just going to be y squared, so I'm just going to do that. Now we can work out the radius, but we already know this length. We already know that that length is 4 square root 17. So the radius is 4 square root 17. So r squared would be the square of this, which is 272. And so the answer would be the following. Like that. And then lastly, it says find the tangent to the circle at point B. So a tangent to the circle at point B would be something like that. Okay, now that's not too difficult, because we know from our Euclidean geometry of grade 11 that, okay, I haven't done this very nicely, it's more like, it would be more like that. I didn't draw the circle that great. But we know that when you have a tangent that is connecting to a radius, see there, you've got a tangent hitting a radius, we know that the theory tells us that this is always 90 degrees. So what I can do is I can say that the gradient of the tangent multiplied by the gradient of my line BE must always be -1. Why? Because that is what we know when two lines are perpendicular. So then I can get the tangent gradient, because I already know tangent of BE, we worked it out earlier, as a quarter. So I can put a quarter here. I can then solve for the gradient of the tangent and get -4. Then all I need to do is I then have my tangent gradient, so I can say -4x plus c, and then I can just plug in a random point on that tangent line. Remember that tangent line was here, to get c, and that point that I could use is b, which is -4 and -4. So I can say -4 and -4, and so c is going to be equal to -20, and so therefore y is equal to -4x minus 20. So let's get started. So let's just see if there's anything interesting here that they haven't told us. So, okay, the circle's center is N. So that is the center. For any of you who are like very theoretical and you're like, yeah, but how do we know that that's the center? There, they tell us it's the center. Passes through A and B. B, C, and D are joined to form a parallelogram. Okay, so this shape here is a parallelogram such that BE is parallel to the x-axis. Okay, so that's important. BE is perfectly parallel to the x-axis. Great. CD is a tangent. Okay, so CD is a tangent. What's the 6? Oh, and CD is 6 units. Oh, okay, so they've given us the length of this line. That's interesting. Right, so it says write down the length of the radius of the circle. Okay, so for 1 mark, some people are thinking, distance formula. You could use the distance formula if you wanted to, and you could do it between N and A, but can you see that it's completely vertical? Because look at the x values. They stay the same. So you don't have to use the distance formula, but if you did, it would still work out. But we can just look by inspection. To go from 3 to -1, what is the distance? It's 4. So the radius of the circle is 4. Okay? So the radius is 4. Let's just remember that for later. Now it says calculate the coordinates of C. Well, you see, C would be directly above. Well, how do I know that? I know that because I know that this line is parallel to the x-axis. So this line is also parallel to the x-axis. So this radius always hits a tangent at 90 degrees. So if this is parallel to the x-axis, then this line must be parallel to the y-axis. And that is why it has gone directly up like that. Okay? So C would have x coordinates of -1. Why? Because you can see it's -1, -1, -1. That doesn't change. But this distance over here would be 4, because it's the radius. So from N to C would be 4 units. So if you add 4 onto 3, you're just going to end up with 7. So C's coordinates would be -1 and 7. The next question, calculate the coordinates of D. Now that's very easy because this length is 6. So it's just going to move 6 along, but it's not going to change in the vertical direction because this line is completely parallel to the x-axis. So we can just move along 6 places. So you look at this x value and you just add 6 to that. So that would become 5, but the y value would still be 7. So this would be 5 and 7. And then they want you to now find the area of triangle BCD. Now remember, to find the area of a triangle, we know that it's either going to be half base times height or half AB sin C. We only really use this one if we have angles that we're busy with here, but there's not really any angles, and this mark allocation would probably be a bit higher if we still had to go work out some angles now. Okay, so I'm going to scrap that one. I don't think it's going to be that one. So what we need is a base and a height. Now a base and a height make 90 degrees with each other. So if you have a triangle that does this, for example, and you decide that this is your base, then your height must make 90 degrees. So this is not your height. This is not a height, okay? Because these two would not be making 90 degrees. So your height is actually this part over here. So this part here is your height. Even though it's not part of the triangle, that is still the height of that triangle. Okay? So if I look at this triangle, we could use this as the base. That could be your base. Then your height would be this. Just so that these two can make 90 degrees. So your base is still the 6, and your height is going to be this part over here. Now, all of these are 90 degrees because we know that this line was parallel to the x-axis. So we know that this line is perpendicular to the, parallel to the y-axis, which means that this is parallel to the x-axis. So everything's pretty easy to work with here. So what that means is that this point is going to have an x value of -4, and its y value, well, is going to be 7. Because everything along this line has a y value of 7, because we're not moving, we're just moving parallel. See that? So all the y values will remain at 7 there. So then I can easily work out this height by simply looking at the vertical distance from -4,2 to -4,7. That is a length of 5. So the height of that triangle is 5, and the base of that triangle is 6. So the area can now be half base, which is 6, times height, which is 5, and this gives us 15. If they don't give you anything, just say units, or square units, or units to the power of 2, but I think I'll just say square units. Alright, so now moving on to the next part. I've tried to fill in as much of the information from the previous parts as I could. So now they say the circle centered at N is reflected, nightmares, is reflected over the line y equals to x. Oh my goodness. So the line y equals to x is a line that does this. Okay, it's the line where we take inverses. So like if you have this coordinate here, which is at 3 and 2, when you're reflected over that line, your x and your y change, because that's why it's called y equals x. So the y's become x's and the x's become y's. Okay, so they're going to be reflecting it across that line. So they said reflected. M is the center of the new circle. Okay, so M for Matthew is going to be somewhere here probably. So M would be probably somewhere over there because they're reflecting it across that line. M is the center of the new circle. The two circles intersect at A and F. Okay, so there's going to be a bit of, I'm not going to have space to do this, but we're going to have a brand new circle. Okay, I'll try to do my best. We're going to have a brand new circle that's going to, they said at A, and then it would go round, and then it would come up like this, like that. And, okay, so there would be a circle there, and they said that the two circles intersect at A. Okay, so we can see they intersect at A and F. So F would be this point here, where the two circles are intersecting. So that would be F. Okay. It says calculate the length from N to m. Okay, that's easy, because if you, as we said just now, if you reflect across this line, so if you take this coordinate and you reflect it to m, the coordinates just switch around. So this would just become 3 and minus 1. Okay, so now you can work out the distance of nm using the distance formula. So let's just write that down: x2 minus x1 squared plus y2 minus y1 squared. Okay, so I'm just going to quickly go fill that in. So that would be, for example, 3 minus 1, and then minus 1 minus 3. And if we had to go fill that all in, we would end up with 4 square root 2, and then if we round that to 2 decimal places, we end up with 5,66. Okay, so I've erased everything so I can just show you guys this. We know that we're reflecting over the line y equals to x, okay? Now, that's a line that normally goes through the origin like this. But that line is also going to be on point A. How come? Because here, the y and the x are the same. Can you see that? So, any point on the line y equals to x has coordinates like this: -2, -2, 4, and 4. The y and the x are always the same on that type of line y equals to x. So then I know that this point is definitely on the point A, or this line is going to be gone on A, and it's going to go through 0. And so f is going to be this point over here. The reason is that the two circles, if I draw this other circle again, we know it goes through A. Okay, it's obviously going to go much bigger than that, but it would come back around. It's very difficult to draw it actually, but we know it goes through A because it says that the two circles intersect at A. You wouldn't actually see this part, it would go away from the page, and then it would eventually come up like this, through F, and there. Why do I say that it's also going to go through F? Well, think about this. Let's say we have this point. Okay, so this point here maybe is, I don't know, maybe this is 2 and 7. Okay? So if you take 2 and 7 and you take the inverse of that, well, that's going to be somewhere over here. Okay, so that's maybe there. So those two parts are never going to intersect. This part and this part are never going to intersect each other. Maybe I have a point here which is maybe 3 and 6. Well, if I take the inverse of that, that's going to be somewhere here. That's going to be 6 and 3. So these two dots are never going to intersect. But what if I look at, for example, this point over here, which is on the line y equals to x? So maybe its coordinates are 4 and 4. I don't know, we're going to still work that out. If you had to take the inverse of that or flip it over, you would switch the x and y's around, and that's still going to stay 4 and 4. So it will be 4 and 4 on both circles, so it means that the circles are intersecting at that point. You might have to take a few moments just to try conceptualize or to process what I'm saying here, but the only two places where these two circles are going to intersect each other are going to be on the line y equals to x. Okay? I sat here for a few minutes thinking about this, okay? This didn't just come naturally to me. So if you're thinking right now, like, what the heck is going on? That's normal. I sat for a few minutes. This one's actually quite interesting to understand. Okay, so the point where these two circles are going to intersect is going to be on this line y equals to x. So what I'm going to do is I'm going to try and find the coordinates of f and a by saying that it is the place where the straight line y equals to x intersects this circle. Okay, because I know the equation of that circle would be x plus 1 and y minus 3, and we already worked out the radius earlier as 4. Remember we said this radius was 4, so then if you say 4 to the power of 2, that would be 16. So that is the equation of that circle. Then we've got the equation of this line y equals to x. So to find the place where these two intersect, I can sort of substitute this one into the circle's equation. Okay, and so that would be x minus 3 squared equals to 16. And then guys, I'm just going to quickly rush through this now. Can I tell you why? It is load shedding while I am busy recording this right now. The power was supposed to come on and my battery has 11 minutes left, and if this laptop switches off, then I lose the last 1.5 hours of recording that I've been doing. So I'm going to quickly go and solve this for x. You guys are pretty good at that by now. And when you do that, you should end up with x equals to -1 or x equals to 3. If you then had to go and work out the y values for each of those, this one would be y equals to -1. And then for this one, it would be y equals to +3. So the coordinates of A we already have as -1 and 1, and the coordinates of F we have as 3 and 3 now. So all that we now need to go and do is find the midpoint of AF, because that's what they're asking us for. So the midpoint of AF is just going to be x1 plus x2 over 2, y1 plus y2 over 2, and so that's going to be -1 plus 3 over 2, and then -1 plus 3 over 2. And if you had to go and work this out, you will end up with 1 and 1 as our final answer over there. So for 6 marks, we have to simplify this expression as much as possible. So for the sin 140, we know that that is the same as sin of 180 minus 40. For the sin of 360 minus x, well, as long as it's on the cast diagram, we can just say that that's going to be sin x, but because it's in this quadrant, sin is negative in that quadrant, so we're going to say negative sin x. Cos 50 is already as simplified as it can be, so we'll leave that one alone. Tan of negative x, well, to modify that, you're not going to take this minus out as a common factor, guys. Remember that that's not the way it works. If it doesn't look like one of these, then just add 360. Okay, so we're going to add 360. Now, when you add, the order does not matter. So I can change this to 360 minus x. And then let me just go one step further. So this will become sin 40, because sin is positive in this quadrant, the 180 minus quadrant. So it will just be sin 40, then negative sin x, then cos 50, and then negative tan x. This will become negative tan x because tan is negative in that quadrant. All right, now some learners panic when they see these negatives. They think, oh, we can't cancel these because this one is for sin and this one is for tan. It's actually not true at all. You could think of these as negative ones if you wanted to, and they can cancel each other now. So what we are left with is sin 40 times sin x over cos 50 times tan x. Now, let's just quickly have a look here. Don't worry about these two over here. Let's just look at this tan x. We know that tan, I'm going to write over here, we know that tan is the same as sin over cos. Okay. Now, let's just take a look at this part over here. We can think of that part as sin x over 1, and then we can say multiply by cos x over sin x. See, I'm just doing this part here. And so what happens is that these sins actually cancel, and you're just left with cos x over 1. So that part there is sin 40 over cos 50, and then all that this whole thing actually ended up becoming was cos x over 1. Now, whenever you see sin and cos like this, and the angle, if you add those angles together, what do you get? 90. Cha-ching! As soon as you see that, you're onto something. Life is good. So you can choose to change one of them, okay? Just one of them. So if you change this one, then this can change into cos 50. It's just called cofunctions, and you don't have to show the cofunction. Some students always say, yeah, sir, but my teacher said we have to show it. You don't. In your final exam papers, you don't. So like if you have sin 40, you don't have to say that this is the same as sin 90 minus 50, which is then the same as cos 50. You don't have to show that. All that I want you to remember is that if you have sin 20, then the opposite of that is cos 70. If you have sin of 5, then the opposite of that is cos 85. If you have cos of 15, then the opposite of that is sin 75. You see, it just switches to the other one, and then the angles add up to 90. That is all that you do. So you're going to go and change any one of these. I'll just change the top one, so that can become cos 50. And then the cos 50 we still have at the bottom. We're not going to change that one. That would be a bit silly of us to do, because then we're never going to get anything to cancel out. And so if we cancel now, we end up with a final answer of cos x. Here we have an identity. Alright, so with the identity, we obviously want to prove that the left-hand side is the same as the right-hand side. Okay, so can you guys see at the top here, we almost have a trinomial looking expression, right? Well, let's first say that we're going to start on the left-hand side. So can you see that this is like a trinomial? It's almost a trinomial, but these two are not the same. So what we have learned to do in the past, we learned this in grade 11. So if you are in grade 11 now, you've learned it this year. If you're a grade 12 learner, you would have learned this in grade 12. In grade 11, is that if you have sin squared x plus cos squared x, we know that that's always equal to 1. Then you're always just going to use this to try help yourself change that, okay? And you're always going to try change the thing that has the square. So what I'm going to do is I'm going to say minus 2. And then I'm going to put a bracket, and let's quickly take this expression, and let's get the sin squared x by itself. If we do that, you end up with sin squared x is equal to 1 minus cos squared x. So I'm going to replace this sin squared x with 1 minus cos squared x. So 1 minus cos squared x. Okay? Then the rest is all the same. And then the rest, I'm not going to touch anything just yet. Okay, now I'm just going to multiply the 2 in, so that gives us minus 2 plus 2 cos squared x plus cos x plus 1. And then at the bottom, okay, let's go work on this one. So when you get something that's like a ridiculous number, like bigger than 360 or negative, then you just want to minus 360 or add 360, depending on which one you need to do. So here we're going to minus 360. And so if you had to use that cos 540 minus x, if you had to minus 360, that gives you cos 180 minus x, and that's negative cos x. So we can change this to negative cos x. So we're actually going to have two negatives now, because this negative was already there. Now I'm just going to simplify at the top. So at the top you're going to end up with 2 cos squared x plus cos x minus 1, because this is minus 2 plus 1, which is minus 1. And then at the bottom, we'll end up with 1 plus cos x. Okay, so now to factorize that, we're just going to have our two brackets because it's a trinomial. It's probably going to be a 2 cos x here, and then a cos x over here, and then a 1 and a 1. You might have to pause and just figure this one out for yourself, but it's going to end up being a plus there and a minus there. And then at the bottom, we have 1 plus cos x. Now, these two are the same. The order doesn't matter when you plus, so we cancel them out, and then we can say, therefore, the left-hand side is the same as the right-hand side, because we've got it over there. With these types of questions, I typically like to just draw a little diagram. You don't have to, but it works out quite nicely. So, like, I would definitely recommend it. But now some students, okay, so you guys, let me quickly show you something. You get two types of questions. Sometimes you get questions like this. They'll say sin theta is equal to 3 over 5, and theta is bigger than 90. Then you got to somehow try to figure out which quadrants you're in. So like this part here would tell you that sin is positive, so that could be there and there. And then they would tell you that the angle is bigger than 90, which could be there, there, and there. And then you would draw it in this quadrant because both of them are there. Okay? But then when you get questions like this, they're giving you the angle. See that? They're telling you what the angle is. It's 36. Here they didn't tell you the angle, so you had to figure out where you were. But 36 is in quadrant number 1, right? Because that's from 0 to 90 degrees. So we know the quadrant, so we can draw our triangle immediately. Now what I like to do is I just put a little 1 over here, because I know that sin is opposite over hypotenuse, or some students prefer y over r. So that means my opposite is, and my angle 36 is here. So I can say 1 minus square root of 1 minus p squared, and I can put my 1 there. I always advise learners just to find this angle, just in case you've got a teacher who's going to try to catch you out there. So you just say 180 minus 36 minus 90, and this should be 54 degrees. Just put it there just in case you will need it just now. Okay, now what I then do is I just go do a bit of Pythagoras over here just to find this missing piece. So let's call that missing piece, I don't know, we can call it x. So we can say that 1 squared is equal to this 1 squared plus x squared, and that means 1 squared is equal to 1 minus p squared, because this 2 just gets rid of the square root, plus x squared. And then if I had to get x squared alone, I'm going to end up with p squared, actually, because the 1's are going to cancel. And so if you take the square root, x is going to be just p. You could say plus minus p, but because this is a positive x value, let's just say positive p. Okay, now that we have the triangle, we can go and answer their question. So their first question is tan 36. So we go to the 36 and we use tan, which is either opposite over adjacent, or if you prefer, y over x. And so that's going to end up being opposite over adjacent, and so that's going to be the answer, just like that. Cos of 108 needs to be simplified first. So cos of 108 is the same as cos 180 minus 72. Can you see it? 72. What are we going to do? What are we going to do? It's double 36. So when you see double, we're going to use the double angle formulas. But let's just simplify this. This becomes negative cos 72. And so here you have your choice of which cos 72, because it's a double angle, so you can choose any one of these. I'm just going to go with this middle one. So what I can do is I can say that now don't worry too much about this negative. It's going to get in the way a bit, but we can just say negative cos 72 is the same as negative. Then in brackets, we can change the cos 72 into this one. So it'll be 1 minus 2 sin squared of 36. Okay, so I just used this one here. And then I'll multiply the negative in, so negative 1 plus 2 sin squared of 36. And then we're almost good to go, so we say minus 1 plus 2, and then sin 36, we already know that that's this one up here at the top. Or you could go work it out again from the diagram, and then it's to the power of 2. Because they said sin squared over here. So now, if you square this square root, the square and the square root cancel each other out. So now you would be left with minus 1 plus 2, and then in brackets, 1 minus p squared. And so that's going to end up becoming minus 1 plus 2 minus 2p squared, and so that's going to be 1 minus 2p squared. In this question, they are asking us to derive a formula for cos theta plus beta. Now, some of you looking at this, you would say, yeah, but this is already on our formula sheet. We already know what this is. But they this is almost like they're asking you to do a proof. So what we do, guys, is we need to make this into a minus. So what we can say is that cos, so I'm taking this one now, so let's just write this one down. Okay, now that is the same. Would you agree with me that that is the same as this? Right? It's the same thing, because this is a plus, and this is also a plus. But what's nice now is that this part is a minus, and so is this. Okay, so now we can use this little formula. But be careful though, this part is the same as this part. This minus is this minus. And then this angle here is now this angle over here. Okay. So what we can now do is we can copy this over here. So that's going to end up becoming, they said that it becomes cos theta, then cos of the blue one, but the blue one for us is now this. So you might have to just pause and think about what we're doing here. So now that's that. Then there's a plus over here, so we put a plus, and then it's a sin of the yellow angle, which is theta, and then sin of the blue angle, which for us though is minus beta. Okay, so we do that. Then we need to just go and simplify this part and this part. So we know that cos of minus beta just becomes cos beta. Okay, but then sin of minus beta, that normally becomes negative sin beta. Okay, and if you're confused about why, well, that's because of the following. If I have cos minus beta, what I do is I add 360 to that because it's not on the cos diagram, and that's the same as 360 minus beta, which is then cos beta. For the sin one, if we have sin of negative beta, then in the next line you can add 360, which is then that, and then that is in the negative quadrant for sin, so we get that. So now I'm just going to go change those to that. So that'll be cos alpha, and then cos negative beta just becomes cos beta, and then plus sin alpha. And then this one we said becomes a negative. So I'm going to multiply that with a negative. Now, this whole term is now negative, right? So what ends up happening is that this negative and this positive, they will combine to become a negative. So we now end up with cos alpha, cos beta, minus sine alpha, and sine beta. And this is the formula that we already know from our formula sheet, but this question was almost like doing a bit of a proof. This question looks pretty interesting. So the first thing that, I don't know, as you practice these things, you begin to see little patterns, but the first thing I can see is that we're probably going to have to do something with all of this up to here. Because this 6 and this 4, if you add them together, you get 10, right? So what I would do is, let's just quickly write this down. And so what we're going to do is, I think this will work. We're going to change this to 4x plus 6x. You see that? Because that's still 10x, but what I like about that is that these are also 4x and 10x. So this could be something, okay? Maybe it doesn't work out, but I've done this for long enough to know that if you do something that makes sense, like changing the 10 into 4 and 6, it's gonna work out. Just watch, guys, see what happens. So here we're gonna end up with 2 cos 6x cos 4x minus. Now here I would use a compound angle. And oh, by the way, you never want to multiply this minus inside there, okay? We don't do, I've seen students trying to do that. We don't do that. We're rather going to go use a compound angle over here. Now we know that on our formula sheet, cos of alpha plus beta is the same as cos alpha, cos beta, minus sine alpha, sine beta. So we're going to put it in a bracket, because this minus can get a little bit dodgy. So we put it in a bracket. That's important. Whoops. So we're going to say cos 4x, cos 6x, minus sin 4x, sin 6x, and then plus 2 sin squared x, which we don't really care about that part right now. This one's pretty random. That's a pretty random one over there. Okay, so now what we're going to do is we're just going to go multiply that negative into the bracket, so that'll become minus cos 4x cos 6x plus sin 4x sin 6x plus 2 sin squared x. Okay, now if we look carefully, this part and this part, they are the same, although the order of these two are different, but that doesn't matter because when you multiply it doesn't matter. So that's just going to become cos 6x cos 4x, because 2 minus 1 is just 1. So that's what we have there. And then over here we've got sin 4x sin 6x plus 2 sin squared x. Oh wow, this is beautiful. If you look at this part, maybe just let me rearrange this to become sin 4x. Oh no, wait, let's leave it as sin 6x sin 4x. If you look on your formula sheet, this is another compound formula. We can see that it actually looks like, oh, that's not even on the page. Give me a second. So what we have is we have this one. See, cos plus sin sin. So we're going to convert it back now. So that means we're going to end up saying, oh, I'm so silly. We had it right here as well. Okay, so that's just going to become cos of 6x minus 4x. Oh, this is actually a beautiful question, guys. Okay, so there we've done that. And so now we end up with cos 2x plus 2 sin squared x. Now this, on our formula sheet, we can now expand that into any one of these. Now I would say, let's go for this one, because it's going to tie up nicely with that one. And so what we would end up with now is I'm going to change it to 1 minus 2 sin squared of x plus 2 sin squared of x, and these two things are now going to cancel out, and so the final answer is 1. Guys, this was a really good question. I do hundreds of these questions, and this one was actually really, really good. So I would definitely make sure, if I was you, that you understand this one. It's really good. I could definitely see them asking something like this. For this question, for 7 marks, hello, don't see that too many times with a general solution. We have to determine, the general solution, just like I said. So what we can possibly do is, the first thing I identify is that this is a double angle, so we could change that using this formula over here. I think that's where I would start. So we can say tan x is equal to 2. Now we're going to expand this part here, so it's going to be another 2 sin x cos x. So that's going to end up giving us tan x equals to 4 sin x cos x. Now tan is sin over cos. We typically always going to change that. We're going to multiply the cos x over now. So we're going to end up with sin x equals to 4 sin x cos squared x. Now what some learners do, be careful here guys, this is what a lot of learners do, and this is incorrect, is you would take this sin x and this sin x and you would cancel them out. You would cancel them, but that's not what we do. What we rather do is you rather take everything to one side. Okay? A lot of you are guilty of that. I've seen this a lot. So we rather do that, and then we rather factorize. So we can take out a common factor, which is sin x, and then we'd be left with that over there. There we go. Okay, so now we can say, therefore, sin x is equal to 0, or 1 minus 4 cos squared x is equal to 0. And so we can say sin x is 0, or, okay, so we'd say sin x is 0, or 1 is equal to 4 cos squared x. Then we can divide by 4, so we're going to end up with sin x equals to 0, or a quarter is equal to cos squared x. Now we're going to take the square root over here, so that means that cos x is going to be, now remember, you're taking a square root, so you're going to say plus and minus the square root of a quarter. But if you had to work out the square root of a quarter on your calculator, it's just a half. Now they said that cos is negative, so we're going to say therefore cos x is going to be negative a half. And so this becomes our brand new question now. Sin x equals to 0, or cos x equals negative a half. Now we can just go ahead and do the general solution like we normally would. But if you've ever watched some of my videos on general solution, you would know that I use a different technique, and your teacher might do this as well, whenever you have sin or cos and it's equal to 0, 1, or minus 1. Because think about this. 0, how are you going to get your reference angle? Like, which quadrants are you even going to work in? Is 0 positive? Is 0 negative? Are you going to work in all 4 quadrants? What are we going to do? Well, whenever it's a 0, a 1, or a minus 1, what I tell learners to do, and your teacher might do this as well, there are many teachers who do this, is you just draw the sin graph quickly, just a basic sin graph, and you see where is it equal to 0. Well, it's equal to 0 for the first time over here. Okay, so that's at 0 degrees itself. So I say x equals to 0, and then I say plus k. Now don't say 360. This is a different technique. What we're going to see is how often do we see a 0. So we see a 0 here again, and again over here, and it would just keep repeating if we had to keep drawing this graph, right? It would just keep doing that. So this is 0 degrees, this is 180 on a sin graph, this is 360. So it seems to be repeating every 180 degrees. And then we just say k is an element of z. And that is it. That is all that you need to do for this one. If it said that sin x was equal to 1, for example, then you would also draw the graph. You could use quadrants for this if you wanted to, but you just draw the graph. And you ask yourself, where is it equal to 1 for the first time? Well, it's equal to 1 over there. And then where would that happen again? Well, that would probably be over here. So then it would be at 90 degrees. Okay, so you would say x equals, this is just an example, by the way. So you'd say x equals to 90, and then you would see how often it repeats. Now, if you look at this jump, that's 360. So if it was that, you would have done that over there. Okay, so the graph method works really nicely when it's 0, 1, or minus 1. You don't have to go get reference angles, quadrants, all of that stuff. Okay, so for this one, it's just going to be, let's just summarize that again. K180, K is an element of z. Okay, now we need to go do this one. So this one says that cos x, so this is one of our answers, right? Don't forget that. So this one says cos x is negative a half. So we need to get our reference angle. We don't put the negative on the calculator. So we just say shift cos of a half, and that's going to give us a reference angle of 60 degrees. Now the negative tells us that we are in the quadrants where cos is negative. So that would be quadrant 2 and quadrant 3. So for quadrant number 2, we could say x is equal to 180 minus, because that's what quadrant 2 says, and then you say your reference angle, and then you say plus k times 360, k is an element of z. And so that's going to end up giving us 120 plus k 360, k element z. Then in quadrant number 3, it's x equals to 180 plus, because that's what quadrant 3 is all about. It's 180 plus. Then you put your reference angle plus k 360, k is an element of z. And if we had to go solve this, we end up with 240 plus k 360, k element z. So our three answers for this one would be this one over here. Sometimes they won't put the 0 because 0 is like 0 is nothing, right? So you could just say x equals to k180 if you wanted to. Here's our second answer, and here's our third answer. The first thing I want to mention is that this question has got multiple parts, but I just couldn't fit everything onto one slide. Okay, so we are going to have more questions coming after this one. So here they tell us that in the diagram below, the graph of f of x equals to negative 2 sin x, okay, so they've drawn that for us, is drawn over the interval minus 180 up to 180. On the grid provided in the answer book, okay, I'm just going to use this as my answer book, but you guys will be given one in your exams. Draw the graph of this over the same interval, show all the intercepts with the axes and the turning points. Okay, so they want us to show all the intercepts and the turning points. Now guys, when you have to draw a cos, sin, or any trig graph, you're just going to use your calculator. Okay, and I'm going to show you exactly how to do that right now. Okay, so what you're going to do is you're going to put your calculator into table mode. Now your table mode might be a little bit, like, it might be a different number, because I've got the silver Casio, most of you have the, I don't know, blue, pink, black and blue. That's the one I had, the black and blue one. So yours might be a little bit different, but what we're going to go do now is we're going to go full in our graph that we want to draw. So our graph is going to be cos x minus 60. Don't worry that it says f. X minus 60. That's just the graph that we want to draw. And we can say equals. We don't have another graph that we want to draw, so we just skip this one. Our starting point is going to be minus 180, because that's where our graph starts. Our ending point will be 180, because that's where our graph ends. And then the step is just going to be 90 for this one. Okay, I'll explain that a little bit just now, but the step is just going to be 90 for this graph, and then we can say equals, and there we go. I'm just going to quickly write these down on a piece of paper, because as soon as I try to write on the screen, this stupid calculator just disappears. It's got like a glitch or something. Maybe it's because I'm using the cracked version, not the paid one. I don't know. Don't judge me, guys. So I'm just quickly writing down these values for us. Alright, so I've got all the values written down. Now, I said that the step was equal to 360. I mean, I didn't say that, I said 90. So the way that it works, there's actually a formula for step. Step is equal to period divided by 4. So I know that this here is a normal cos graph. Yes, it's been moved left or right because of that, but it hasn't been, they haven't made it smaller or bigger. Like they haven't changed it from this to that, for example. That would only be if there was a number over here. Like if they said something like cos 2x, then I know that the period has changed. But for a normal cos graph, which only has a 1 over there, there's no other number there, then I know that its period is normally 360. So my step is then 360 divided by 4, and that's why I chose 90 on my calculator. Okay, but if it was like cos 3x, then I know that this actually makes the period 120 degrees, and then my step would have been 120 divided by 4, and so my step actually would have been 30 degrees if I had it like that. So just remember this, step is equal to period divided by 4. Okay, now I'm going to go plot all of these points. So I'll quickly write them out for you. These are the points that I got on my calculator. I hope you got the same. Okay, so the first one is minus 180 and negative 0.5, so that would be over here. It's so nice that they've given us this grid. Such kind people. So then it's going to be minus 90 and negative 0.866, which is about there. Okay, and 0 and 0.5, that's about there. 90 and 0.866, which would be here. And then 180 and negative 0.5, which is there. And then we got to go draw that as neatly as we can. So I get something like that. Now they have asked us to please label all the intercepts with the axes and the turning points of the graph. Okay, so the turning point, oh, I didn't do this very nicely, would be seen a lot better if we did this on the actual grid paper that they provided. But what we should know is that this is a cos graph that has been moved 60 degrees to the right. Okay, so a normal cos graph, let's just quickly draw a normal cos graph. A normal cos graph would normally start over here, and then it would go like that. But now they've taken that graph and they've moved it 60 degrees to the right. So that means that this will be our first turning point, which is going to be 60 degrees to the right. So that would be, that would actually be this point over here, if I did it accurately. And that would be at a coordinate of 60 degrees and 1. Because normally it would be at 0 and 1, but then they moved it 60 degrees to the right. Now this this x-intercept on a normal cos graph would normally be at 90 and 0, but now if you add 360 to that, it should be over here, where it would be at 150 and 0. Okay, so we're showing the intercepts, and then this point over here, if we had to carry on, this would normally happen at minus 90, this x-intercept, but if you move it 60 degrees on, it would be at negative 30. Okay, so this would be at negative 30 and 0, and then this turning point over here would normally be at minus 180 degrees, but if you move it 60 degrees on, then this would be at minus 120 now. And then I checked on the memo, they don't expect you to know the y-intercept because that's a bit of a technical one to do, but yeah, that would be our graph over there that we've just drawn. This one says write down the period of the graph of f if it's got a 3x now. So the graph of f, if it's got a 3x now, so what that means is that all the x's get replaced with 3x, so it looks like this now. See that? Now remember, when they put a number in the front of x like that, that number determines your period. We call this is sometimes a k number, because usually it's like y equals to a sin of k x minus p plus q. So this is a k number. And there is a formula for k. K goes like this. Original period over the new period. Okay, so if k is equal to 3, what is the original period? For a normal sin graph. Well, that's normally 360, right? And then this is new period. So if you had to get the new period by itself, you're going to end up with 360 divided by 3, and that's going to give you 120. And so this answer is 120 degrees. 7.3, it says use the graphs, and this is only for 1 mark, so don't be too intimidated. It says use the graphs to determine the value of x in this interval for which f of x minus g of x is equal to 1. When they say f of x minus g of x is equal to 1, they're talking about the vertical distance between the two graphs, f of x minus g of x. And it's f of x on top. That's the first one. So f of x must be on top. So they're wanting to know where is f of x on top, and it must be exactly 1 unit above the other graph. So I can see a place over here. See there? Oh no, but then the other graph is on top. My bad. Oh, then over here. See there? At that point, f of x is at 1 and g of x is at 0. So if you had to say 1 minus 0, you would end up with 1. And so that is where it is. It's at x equals to minus 30. Now this question says write down the range. Okay, so range is your y values of k if graph k is a half of g plus 1. Okay, so what we can do, they're talking about graph g. Now graph g is, it's the one that we drew. Okay, so that's quite interesting. So it's the one that we drew. Now let's look at the range of graph g. So let's say g, the range, well, that's just going from minus 1 up to positive 1. So we can just say minus 1 to 1, like that. Now, so the range of k, well, you're going to multiply that by a half, and then you're going to add 1. So if we multiply it by a half, so a half of g of x, well, what that would do is it would make the range become minus a half and a half, because all the values are going to be multiplied by a half. And then what we're going to do is we're going to add 1. So we're going to add 1 to that. So we're going to add 1 to each of these values because it's moving the graph up by 1, and so that should take us to positive a half, and then 3 over 2, like that. And I should be adding y is an element here, y is an element, and y is an element. So the final answer would be this one over here. If you prefer to use interval notation, then, set border notation, my bad, you could do it like this, and like that. So in this question, we have been given a diagram. They say that T is a hook in the ceiling of an art gallery. Points Q, S, and R are on the same horizontal plane. Okay, so these 3 points are flat on the floor. Okay, some students do struggle with the whole view of 3D, but that's on the floor. And then there are 3 people observing the hook T. The angle of elevation from Q to T is X, but they've told us that already. QSR is 90 plus X. We've got that. RS, where's that? QRS, oh, that's this one, that's X. QR is 5 units. Okay, so they've told us that. And then TS is equal to SQ, but we can see that they've given us that. Okay, so everything in this statement has been given to us already. The first question for 3 marks says prove that QS is equal to 5 tan x. Now, I don't worry about the 5 or the tan x. What I'm going to go and do is just find QS now. That's all I'm going to do. I'm just going to try to solve QS. Now, I think this triangle here has quite a lot of information, so I'm going to start there. Now, the way I do these questions is the following. So I first choose which triangle I'm going to use. So I'm going to use this one over here. Then I ask myself, is that a 90-degree triangle? So is it a 90-degree triangle? The answer is no. So then the only formulas that I can actually use then would be the sin formula, or the sin rule. You can also write it the other way. You can put the sin A at the top. And the other formula that I can then use if it's not a 90-degree triangle would be this one. These are the only 2 formulas that we can use if it's not 90 degrees. If it is a 90 degrees, then we can go old school and we can go grade 10 formulas where we use sin, cos, and tan, like sin is opposite hypotenuse, cos is adjacent hypotenuse. Those we can only use, though, if it is a 90-degree triangle. Okay, so what I then do is I always try to use this one first. And then if that one doesn't work, or if it can't work, then of course I only have to try use this one over here. So I look for opposites now. So we're trying to find QS. Okay, so QS is our unknown. I look opposite QS. What angle do we have there? Oh, we do have an angle. That's this one. So I know that this side goes with this angle. And then I look for any other opposites. So we've got this side and we've got this angle. And there we go. So we have got opposites. So life is fantastic right now. And so what I would then do is I would say QS over its opposite angle, which is x, and then that's equal to 5 over the sin of 90 plus x. Now this over here is a co-function. Remember, we know 4 of them. We know cos 90 plus x. I'll write the answers down now. Sin 90 plus x, sin 90 minus x, and cos 90 minus x. So they all become the opposite. So this becomes sin, this becomes cos, this becomes cos, and then it's just this one that's a little bit weird. This one becomes negative sin. So what we have here is the sin of 90 plus x. So that's going to be this one here. And so that's just going to end up becoming cos x. And so what we can do then is we can change this to become cos x. And so that would give us QS over sin x equals to 5 over cos x. What I'm then going to do is just get the QS by itself. So that means that QS is going to be equal to, so I'm going to multiply this sin x up to the top here. So QS is now going to be 5 sin x over cos x. then I know that sin over cos is tan, and so that's going to be 5 tan x, and that's exactly what they wanted us to do over there. Now, because we've gone and we filled that in, we went and calculated that, let's just write it down so we know that we actually have it, and then we also have this now as 5 tan x, okay, because they said that those two are the same. Now, the next question, for 5 marks, prove that the length of QT. Now, I don't really look at this part. I just say, okay, I have to go find QT. This is the beauty of maths. The people who designed this question, it can only get to that answer. Okay, there's multiple ways to do it though, so I'm just going to go look at QT. So QT is this one over here. So that's what we need to go and solve. So in this triangle here, this triangle, we know that angle T is also going to be equal to x, right? Because we know that if these two sides are the same, then the two angles must be the same. So let's start off there. Let's say that angle QTS is going to be equal to x, and that is because we have angles opposite equal sides. Well, I should actually say equal angles opposite equal sides. So this over here is also x. Then I could work out this angle over here just by using sum of angles in a triangle. Now you can't just say s, because s could be this, this, or this. So you have to tell them which s. So you're talking about QST. That's the s we're talking about. So angle QST is equal to 180 minus x, and that's just because of sum angles triangle. And so that's going to be 180 minus 2x. So this angle here is 180 minus 2x. Now, in this triangle, this one over here, I can now use the cos rule. It's not a 90-degree triangle, so I can only use the cos rule or the sin rule. And I think the cos rule will work really nicely, because the cos rule works nicely whenever you have two sides, so like x and y, and you have an angle in between them. If you have two sides and an angle in between them, then you can use the cos rule to find the side opposite. So in this triangle, we already know this length, and we already have this length, and we have the angle in between them. So then we can use the cos rule to find the opposite side. Well, let's just draw that a little bit better. And that's what we're looking for, QT. But guys, I'm not even caring about the 10 sin x. I couldn't be bothered about that. I'm just going to go solve QT, and I know that by doing a bit of manipulation and a bit of mathematics, it is going to work out. How it's going to work out? Well, that's a mystery to me right now, because all I see is a whole bunch of tan, and we're going to use the cos rule, but somehow they're saying that the answer is going to be having a sin. How the heck is that going to work? I never know. But I'm just going to go do some basic mathematics now, and we're just going to try it out. So we're going to use the cos rule. And so we're looking for QT, so we can say QT. And then we can say this one, which is 5 tan x. But then it's squared, so I put it in brackets. And then this one is also 5 tan x. And that's squared. And then we say minus 2. And then we've got 5 tan x again. And another 5 tan x. And then cos 180. Sorry guys, this is squashed. Okay, let's try that again. So cos 180 minus 2x. Okay, now we're just going to go simplify a little bit. So that's going to give us QT squared equals to, this is going to become 25 tan squared x, and this is going to become 25 tan squared x. So together, that will become 50 tan squared x. Now this part here is 2 times 5, which is 10, times 5, which is 50. And that's also going to be a 50 tan squared x. And then cos 180 minus 2x. Now a big problem that I see is a lot of learners, they just minus these two from each other. They just go minus that. But that's not correct. You can't just minus them, because this 50 tan squared x is attached to the cos 180 minus 2x. So you cannot minus this one and this one, okay? But what you must do is you take out a common factor. So you can take out a common factor of 50 tan squared x, and then you'd be left with 1 minus cos 180 minus 2x. Now let's quickly have a look at cos 180 minus 2x. We know from a cast diagram that that is just going to become negative cos 2x, right? Because in the quadrant of 180 minus, cos is negative. So now what we have is qt squared is equal to 50 tan squared x, and then we're going to say 1 plus cos 2x, because this part became a negative, so it would combine with this negative to make a positive. Now we have a double angle formula over here. You know on the formula sheet where you can choose 3 of those different cos 2x formulas. I would choose the one that has a minus 1 in it. The reason is I want to get rid of this 1 over here, because in the final answer I can see that there aren't too many terms. There's only one term. So I need to try and get rid of this 1 over here. So that means I'm going to have to choose the cos 2x formula that goes like this. 2 cos squared x minus 1. That's the one I'm going to choose. So it's going to be 1 plus 2 cos squared x minus 1. And now what happens is that this one and this one, they're going to cancel. Sorry guys, I'm going to move up over here. So now we're going to say qt squared is equal to 50 tan squared x. I still don't see how this is going to become that, but I don't care. I just keep going, and I know that mathematics is just going to work out. It's absolutely incredible how it does that, and that gives us 2 cos squared x. Okay, now I know that tan is the same as sin over cos, so I can change this to sin squared over cos squared. So it's going to become, so we can say sorry, I'm just rewriting it just to get a bit of space. Okay, so I can't remember if I forgot that 2 over there, but that's what we have now. And so if we had to go and multiply that, that's actually just going to give us 100 tan squared x times cos squared x. Then I can change tan into sin over cos. And so that means that qt squared is going to become 100, and then I can say sin squared x over cos squared x times cos squared x. And then these cos squared x's, they can cancel. And so I end up with qt squared is equal to 100 sin squared x. Now I can take the square root because I'm trying to get qt alone. And so that's going to be 10 because that's the square root of 100. And then the square root of sin squared is just sin x. And holy moly, look at that. It actually gets to the final answer. I promise you, I did not see how that was going to work, but I've learned over the years that, and I'm trying to install this into you. Don't worry about trying to get to that. Just do maths and you will eventually get to this final answer. You can't go, unless you make mistakes that are wrong, obviously, then it won't work. But if you just keep doing everything correctly, don't worry too much about how it's going to get to that. I only saw that it was going to get to that at about this step here. Up until then, I was literally just going in the dark and just doing maths. And with practice, you just learn what you need to do, and then it does work out. Okay, so let's do the last question now. But I always like to go full in whatever we've worked out, just in case they want us to use that again. So we know that this is now 10 sin x. Okay, so last question says, calculate the area of triangle TQR. Triangle TQR. Okay, so TQR is this one here. So they want the area of that. If angle TQR, which is this angle here, in that yellow triangle, that's 70 degrees, okay? And x is 25. Okay, so x is 25. We're not going to use this x because that's not part of that yellow triangle. That's part of a different triangle, but we're probably going to be able to use the x over here. Okay, so this is actually a very, very easy question because we know that to use the area formula, obviously area is half base times height. But come on, guys, we're not going to use half base times height in these types of triangles when there's angles and stuff. Instead, we're rather going to use the sin formula for area, which is half AB sin C. And so the way that it can work, or the way that this formula works, is that you've got a triangle like this, and you've got some angle over here. So for example, that's some angle C. and then you've got a side A and a side B. So you need the two sides that are next to that angle, and then you can use the sin rule or the sin formula. So in this yellow triangle, we've got this angle 70. See that? We've got this angle 70, and then we've got this side, and we've got this side over here. Let me just draw this out for you guys a bit better so you can see what I'm talking about. So we've got this angle 70, and then we've got this as 10 sin x, and then we've got this as 5. So we can use the area formula straight away. So we can say that the area is going to be a half, and then you just take the two sides, so like 10 sin x, and the other one, which is 5, and then sin 70. Now remember that they've given us what the value of x is. It's 25. So we can just go fill that in now. 10 sin 25 times 5 times sin 70, and then we can just go fill all of this in, and then if you work that out you end up with 9.93, and then you could just say like units to the power of 2 or something like that. In this question we are given a cyclic quadrilateral PQRS. They tell us that TR, so here's TR, and TS, they tell us that those are tangents to the circle. Okay, so those lines are tangents, that's excellent. And angle T is 78, we see that, and angle Q is 93, we can see that. So the first question, for only 1 mark, give a reason why ST is the same length as TR. Well, that just goes back to the theory of tangents. If you have a tangent, or two tangents, that come from the same point, then their lengths are equal. So these two tangents both come from T, so their lengths will be equal. Okay, so that's just going to be tans. This is the reason, tans from common point. Okay, so the next question now, 9.2.1, says calculate the size of S2 for 2 marks. Okay, well this one's pretty easy because in this triangle, that is going to be an isosceles triangle because we have just shown that these two sides are already the same. Okay, so we already know that ST is equal to TR, so we can say that S2, angle S2, must be the same as angle R2 because of equal angles opposite equal sides. So if, for example, S2 is x and R2 is x, then to work out x, you could just say 180 minus 78, and then you divide that by 2, because they're both going to be the same. And if we had to go work this out, we're going to end up with 51 degrees. Oh, and I should have said what the reason was over here. We were saying sum of angles in a triangle. So that means that these are each going to be 51 degrees, 51, and 51. The next question for 2 marks, calculate S3. So what we know is that this shape here is a cyclic quadrilateral. And we know that the external angle of a cyclic quadrilateral, so this whole angle over here, will always be equal to the interior opposite angle. So that whole angle is WSR. We can call it WSR, like that. And we can say that that's equal to 93. And that's just because of exterior angle of a cyclic quad. And so if you had to then go work it out, you would see that angle S3 plus angle S2 must be 93 degrees. So S3 plus angle S2, which is 51, must give us 93. And so if you had to go work out angle S3, you're going to end up with 42 degrees. 42 degrees. Just want to let you guys know that this question does carry on the next slides. Okay, so on the next slide, we're going to have this question over here, and then we are also going to have this question over here. So I just couldn't keep everything on one page, but here we go. Let's start. So they tell us that in the diagram, BE and CD are diameters. Okay, so we can see that BE and CD are diameters, and they're going through the center, which they are calling M. They said chord AE is drawn to cut CD at F, and then they say that that angle there, they're saying AE is perpendicular to CD, and they said that angle C is X. Okay, so everything that they've mentioned is already on the diagram. So the first question, for only 1 mark, give a reason why AF is equal to FE. So they want to say, why is this side equal to this side? Well, this goes back to the very beginning when we started learning these theorems in grade 11, where if you have a center circle, or a circle center, and you have a chord, and if you have a line going from the center perpendicular to that chord, then automatically it means that this length is going to now be the same as this length over here. And the reason for this is line from the center, and then we say perpendicular to chord. Line from center, perpendicular to chord. Next question. Determine, giving reasons, the size of angle M1. Alright, so what we can do here is we can realize that angle M1 is a center angle. So it's the center angle, and it is made by chord CE. I'm not drawing chord CE, like I'm not telling you that you'd have to draw chord CE in the exam. I'm just showing you something. Chord CE makes angle M1. Can you see that? That's what it does there. Now chord CE also makes this angle over here. See that? Both of those angles, A1 and M1, they both come from the chord CE. Now M1 is at the center, A1 is on the circumference. So we know that if you have a circle and you have a center angle, that center angle is always going to be double any angle made on the circumference by that same chord. And that's the angle at center equals 2 times angle at circumference theorem. So we need to quickly go work out A1, but that won't be difficult because we can just work out sum of angles in a triangle over here. So we can say that angle A1 is going to be equal to 180 minus 90 minus x, and that's because of sum of angles in a triangle. And so A1 is going to end up being 90 minus x. So now we can go work out M1, which would be double that. So we could say M1 is going to be equal to 2 times angle A1, and that is because angle at center equals 2 times angle at circumference. So this means that angle M1 is then going to be equal to 2 times 90 minus x, and that's going to end up giving us 180 minus 2x. So I'm just going to fill that in for us. We know that M1 is now 180 minus 2x. We know that A1 is 90 minus x. And so this question for 4 marks, prove with reasons that AD, so this is AD, is a tangent to a circle that would pass through AC and F. So if there was a circle that was through AC and F, it would look something like that. Now, I can tell you with almost 100% certainty that whenever they ask you this type of question where they want you to prove that something is a tangent to a circle, it's normally going to be the converse of the tan chord theorem. Okay, that's normally what it is. So what we do is we look at this tangent that they're saying is supposedly a tangent, and we look at the circle, and we look at this chord, and now we try to pretend that the tan chord theorem is going to work. So if the tan chord theorem did work, we'd know that that means that this angle over here, which is angle A2, must be the same as angle C. That is what we need to prove. Okay, so what we want to prove, I'm just going to write this down for us, just so we can know. What we need to prove is that angle A2 is actually going to be the same as angle C. Okay, because if that is true, then we can say it's the tan chord theorem, or we can see that it's the tan chord theorem is working, and so then we could say converse tan chord theorem. Okay, so if we look in this triangle over here, this triangle ACD, we know that this angle here is 90 degrees, this whole A1 and A2. That's just because this line is a diameter, and a diameter always makes an angle of 90 degrees. So we can say that angle CAD, right? That's CAD. So that's this whole angle over here. We know that that is going to be 90 degrees. And that's just because of angles in semicircle. So then we can say that angle A1 plus angle A2 is 90 degrees, but angle A1 is already 90 minus x. So you can go work out angle A2 now, and what you would find is that angle A2 is going to be equal to x. And so that means that it is actually the same as angle C. So we can say therefore angle A2 is equal to angle C, and then we can say converse, or let's first say, sorry, therefore AD is a tangent, and then we can say converse tan chord theorem. And then lastly it says, given that CF is equal to 6 units and AB is equal to 24, AB is 24, calculate the length of AE for 5 marks. The length of AE. Where's AE? Oh, there's AE. So in grade 10, back in grade 10, you guys learned about something called the midpoint theorem with triangles, and they usually don't spend too much time on that in grade 10, but it's almost like the grade 12 proportionality theorem for those of you that are in grade 12. Some of you watching this might be grade 11. But if you're grade 12, it's almost like the proportionality theorem, but it's a special case of the proportionality theorem when we have the following. If this length is exactly the same as that length, and this length is exactly the same as this length, then the midpoint theorem from grade 10 told us that these two lines are automatically then parallel, and this length will be double this one over here. Okay, so we know that FE is the same as AF. We know that because we proved that, or they asked us that in one of the first questions earlier. They said, why is this length the same as this length? Okay, so we can just say that quickly. AF is equal to FE. That's already been proven. Then we can also see, so I'm working in this triangle here now. Whoopsie, Kevin, that wasn't very nice. I'm working on this triangle here. We also know that this length would be exactly the same as this length. Why? Because they are the radii of that circle. See that? That's a radius, and that's a radius. So we can say that BM is the same length as EM, and that's because these are the radii. So what we then have is, okay, so these two are now the same. So in that triangle, we've now got a perfect midpoint scenario. So what it means then is that FM would be half of AB. And this is the midpoint theorem. Midpoint theorem, okay, from grade 10. So that means that FM is half of 24, which is 12. Okay, so FM is 12. So now all of a sudden we can see that the entire radius, which is the CM, see there, CM, that's going to be 18 units. So CM is 18, therefore the radius we can say is 18. So that means if that's the radius, then this length here is the diameter, so that would be double. So we could say that the length of BE is double 18, so that's 36. Ha! Now we can use Pythagoras in this triangle over here to calculate the yellow one, which is AE. So we can say that AE squared is going to be equal to 36 squared minus 24 squared, and this is just Pythagoras, and if we had to go work out AE, remembering to square root at the end, we should end up with 12. Whoa, what was that? 12 square root 5. Or, if you want to use the decimal form, of course, or 26,83. In this question, we need to do a proof. So it says, prove the theorem which states that angle DFK is equal to angle E. So DFK, oh, that's this one, and angle E. Okay, so this is the tan chord theorem proof. It's very straightforward. What we're going to do is we're just going to go construct two lines quickly. So we're going to construct the line OF, and we will also construct OD. Okay, so I'm just going to construct OF and OD. And then I'm going to let this angle here, this one, the one that we're actually busy working with, which is DFK, we're going to let that equal to x. So that'll be x, okay? Then we need to go work out this little angle here. Now we can do that by using this as a 90 degree. Why is that a 90 degree? Because this is a tangent, and this line that we've just constructed is a radius. So we could work, so let's go quickly say that angle KFO is 90 degrees, and that's just because of tangent being perpendicular to a radius. So then we can work out this little angle, which I will call OFD, and that's just going to be 90 minus x. There's no reason for that, that's just follows from what we've already said. Now, in this triangle over here, it is an isosceles triangle, right? Because we know that OD is the same as OF, because they are the radii. So therefore, this angle, which I'll call FDO, that's also going to be 90 minus x, and that's just because of angles opposite equal sides. So this is 90 minus x. Now we're going to use sum of angles in a triangle to calculate this angle O. So let's call that angle DOF. And we can say that that's 180 minus. Now this angle must go in a bracket because it's one angle. And then this one, of course, we need to do the same. So you do that. And this will be sum angles in a triangle. So if you had to go work out angle DOF, you would eventually, after multiplying the negatives in and simplifying and all of that, you should end up with 2x. Okay, so that's 2x. Now we know that this angle is always double this angle. That's just because of angle at center is 2 times the angle at the circumference. So we can now say that angle E is going to be, or let's first say that angle DOF is 2 times angle E, and that's just because of angle at center equals 2 times angle at circumference. And so we can then say that angle E, angle E is equal to x. And so what we've then showed is that we can then say, so this would come right at the end, therefore angle DFK is going to be the same as angle E. And that's all that we wanted to prove for this question. Please take note that these questions do carry on the next slide. So here's the next question, and the next one, and the last one. Okay, so those are the different questions that we're going to do. I just couldn't fit everything onto one slide. The first question says, well, let's first see what they say. In the diagram, PK is a tangent. Okay, fantastic, so that's a tangent. Chord LS, blah, 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 respectively. Okay, they said that these lines are parallel. Okay, they've shown us that, so that's nice. And then the chords intersect at T. Okay, so the first question for 4 marks, prove that K4, so where's K4? K4 is here, is equal to angle NML. Where are you? NML. Oh, okay, so that's that whole angle. Okay, so when I see K4, I know that that's a tangent, so I can use the tan chord theorem, because this is the tangent, and this is the chord. So what I can do is I can take that chord and try to make any other angles in the circle. So for example, I can go like that. Okay, so that means that this angle S1 is the same as K4 because of the tan chord theorem. So we can say that S1, angle S1, is the same as angle K4, and that's because of the tan chord theorem. Okay, so now we know that this, and then if you look here, these two parallel lines, we know that this angle would be the same as this angle. So we could say that S1 is going to be the same as, they called this NML, and that's going to be because of corresponding angles, and that's because NM is parallel to KS. Okay, and so there we go, we've done it, because we said that K4 is equal to S1, but S1 is equal to that. That means therefore that these two must be the same. So we can say therefore K4 must be the same as NML, and there's no reason for that. That's just based upon what we've already shown previously. Next one, prove that KLMN, okay, so where are you, KLMN? KLMN. Prove that it's a cyclic quad. Well, this is for 1 mark, and you know why, guys? Because it's so easy. We already proved that this angle is the same as this angle. So that's exterior angle of a cyclic quad. So we can say K4 is equal to NMO, and that we already proved. So we can then say, therefore, KLMN is cyclic. Why? And the reason that we can say it's a cyclic quad is because the exterior angle of this quadrilateral is equal to the interior opposite angle. Okay, so remember what we've proven so far, that this is a cyclic quad. I don't know, maybe we'll need that a little bit later. For 5 marks, prove that triangle LKN, I'm actually going to get rid of the cyclic quad. We'll just have to remember that. So LKN, so LKN, prove that that triangle is similar to KSM. So we want these two triangles to be similar. Earlier on we proved that this was a cyclic quad, remember? So because it's a cyclic quad, it means that if something is a cyclic quad, you can also use this type of theorem where you can say that this angle is the same as this angle because of angles in the same segment. Remember, if it's a cyclic quad, you can do that. So if you had to start at this line over here, then you could make this angle and you could also make this angle. Okay? See, because if I put my 2 fingers there, for example, and if I had to go this way, then it would get there. And if I had to go this way, whoops, no, that's not where I was going. If I had to go that way, then it also makes that. Okay, so those 2 angles will be the same. So this angle and this angle. So we can say that M3 is equal to N3, and that's just because of angles in same segment. Now I'm just going to draw that cyclic quad again. Geez, like they're using the cyclic quad a few times actually. Alright, so in triangle LKN, we know that angle L, which is this one, must be the same as angle K in KSM. Okay, so we know that these 2 angles need to be the same. Okay, so we know that this angle needs to be the same as that angle. Now, I couldn't see a direct link between them. There is no direct link between them. But what we can see is that these 2 lines are parallel, right? So if you use alternating angles over here, let me do that a bit better. Then it means that angle M2 is going to be the same as angle K2. Okay, so we can say that angle M2 is the same as angle K2, and that's because of alt angles, and that's because the line KS is parallel to MN. Okay, so this angle is the same as this angle. But now, if I use the cyclic quadrilateral that we proved earlier, and specifically if I focus on KN, and I use angles in the same segment, that KN actually makes this angle. If you look carefully, it makes that angle, but it also makes this angle. If I use this side of the cyclic quad and I try to make angles in the same segment, it makes L1 and it makes M2. So we can say L1 is equal to M2, and that is because of angles in the same segment. So then what that means is that we said that, see, angle M2 is the same as K2, but angle L1 is also the same as angle M2. And so from this, we can say that angle K2 is the same as angle L1. So K2 is the same as angle L1. So they are the same as each other. This is quite a difficult similarity, I will not lie. Okay, so we've got that. And so now we just need the last one. So now we need to just choose the last angles that we haven't used yet. So in this triangle, KSM, we haven't used this whole S, so we can say KSM, that angle, is going to be the same as this angle K over here, which we can call that angle LKN. So LKN. Now remember, the reason for this last angle, that I didn't even have to go and do anything, I just said that they're equal to each other, is because it's the sum of angles in a triangle. Okay, so there we go. We've gone and proved that all of these angles, or all the angles in these two triangles, are the same, and so we can now say that they're similar. So I'll do that now. That was actually one of the most, I think that's the most difficult similarity question I've seen. That was quite a challenging one. So we can then say, therefore, LKN, triangle LKN, sorry, is similar to triangle KSM, and the reason is going to be angle, angle, angle. Now remember this for the next question. Remember that we've proven these similar, because what a good idea is in the next questions, they're probably going to do some weird stuff. Let's have a look. Yeah, okay, so they're doing some interesting stuff in the next question. So let's remember that we've proven that these are similar, so that we can use the ratios. You know the ratios that we normally do for similarity? That usually is needed to solve the next questions. Okay, so I just want to remind ourselves that we've done triangle triangle LKN, and we said that that was similar to triangle KSM. LKN and KSM. Okay, so let's remember that. So in the next question it says that if LK is 12 and 3KN is equal to 4SM, okay, we'll remember that just now, determine the length of KS. So what I go do now immediately, yeah, we can fill it on the diagram if you guys want to, so that's 12, and then I would turn this into a little proportion. So I would say that KN over SM is going to be the same as, KN over SM is going to be the same as 4 over 3. KN over SM, yeah, 4 over 3. So, but this is a ratio now. So for the ratio, I would go fill it in on my diagram as like 4x, for example, and then SM is 3x. Okay, but what I would then do is I'd go straight to this that we learnt about, or that we found in the previous question, and I would make my ratios. So I'll do that, and then that. And then you must give a reason for this, and here you can just say similar triangles. Yeah, there are other reasons as well. Sometimes I say corresponding sides in proportion, things like that. Okay, so what I would then do is I'd go full in whatever they've given us. So we know that LK is 12. KS, do we know anything about KS? No, we don't, so that's okay. We just go fill that in. KN, yes, we know that that is 4x. SM, oh lovely, we know that that's 3x. Oh, we don't even have to go further. We don't need to know what LN is, or KM, because check this out. See guys, this is what I'm trying to show you, is that most of these questions can be solved by using the previous similarity. Okay, and so now we can just go do some solving over here. So I know that this x, they would cancel out, and so I'll do cross multiplication. So 12 times 3 would go there, and then, whoops, and then 4 times ks would go over there. And so then if I had to get ks by itself, I would end up with ks as 9. And so I'm just going to fill that in. Ks, the whole of ks is 9. And let's still remember, guys, that we have proved that LKN, triangle LKN, was similar to triangle KSM. Okay, and I'm going to make our ratios anyway, just in case. You would have had them written down in your paper, like in your exam. You would have had them on your paper from the previous question, but obviously I always have to erase this the whole time. Okay, now they say, if it is further given that NL is 16, okay, so now sometimes they're going to go into a brand new, they're going to go into something completely different, and we won't use this, but let's see. So NL is 16, okay, so NL, okay, there's NL, okay, so that's 16. LS, sure, so many different lengths, guys. LS, okay, we know that LS, maybe I shouldn't highlight everything. LS is 13. Okay, I'm thinking a bit of a proportionality vibe coming on here, because there's parallel lines. KN Kn, where are you, Kn? Oh, Kn is, okay, so we know that Kn was 4x, but we also know that Kn is now 8. So can you see there that x is 2? So then that means that this length here would be 6, because they told us that earlier. We don't even have to show that. This is 8. They told us earlier that Kn over Sm was in the ratio of 4 parts to 3 parts. So that's 8 and 6 now, so that's great. Okay, so it says, okay, we've got everything. Kn is 8. Now it says determine the length of LT. LT. Okay, so LT is over there. Okay, so this is actually very straightforward. Look at this, guys. In this triangle here, we've got 2 parallel lines, so we can use the proportionality theorem. So what we can then say is that, for example, Ln, because we have that length, so we could say Ln over TL, for example, because that's what we're looking for. Let's actually start with TL. So we can say TL over the whole length of NL, which we do have, is then going to be equal to LS over the whole of its length, which is LM. So I'm just using proportionality theorem there. And so the reason you can give is line, parallel, side of triangle, and that is because NM is parallel to TS. And so we can say TL over 16 is equal to LS, which is 13, over LM, which is 19. Okay, and then we can just do some normal solving, and if you solve for TL, you should end up with 208 over 19, or in decimal form, you could say 10,95. 10,95.